Have you ever really stopped to think about the invisible network that powers pretty much everything you do? Seriously, it's this hidden system, just humming along in the background, making our modern lives possible. Today, we're going to pull back that curtain. Let's dive into this hidden world together.
No, really, think about it for a second. Beyond the obvious stuff, what systems had to work absolutely perfectly just for you to get your day started? Well, the answer is kind of like this huge hidden web. And today, we're going to trace some of its threads. You know, the electricity that brewed your coffee this morning, the pipelines that got the fuel to your local gas station, even the water treatment plants that give us clean water on demand, all of these things, believe it or not, rely on one single type of system. It's so deeply embedded in our daily lives, we don't even see it's there. Probably the best way to think about these systems is like they're the central nervous system of our industrial world. Yeah, really. They're the digital brains making real-world physical decisions every single second of every single day. And that brain, it has a name, SCADA. It stands for Supervisory Control and Data Acquisition. Basically, it's a mix of software and hardware that lets industries monitor and control physical processes, whether they're just across the street or all the way across the country. And these systems are, well, they're everywhere, from your local power grid to the International Space Station. Okay, so this image gives us a really great visual of how this all works. Over on the left, you've got the control center. That's the human operators, the servers, the brains of the operation. And on the right, you see the actual field sites, things like power plants, water pumps, pipeline valves. SCADA is that invisible bridge connecting them, turning digital commands into real-world actions. And what is it actually controlling? Well, pretty much all the big stuff, the foundational pillars of our entire society. We're talking the electrical grid, water systems, fuel pipelines, even our communication networks. They're all orchestrated by SCADA systems. Without them, things would grind to a halt very, very fast. But what happens when the very system that's designed to control everything becomes vulnerable? You see, for a long, long time, the whole industry relied on a pretty simple idea for security. If nobody knows how our systems work, then nobody can attack them. This was the myth of security through obscurity. So the key thing to get here is that these systems were intentionally designed to be black boxes. They weren't hooked up to the internet, and they used all this custom software and hardware. The thinking was, unless you had the secret key, in the form of a specific engineering manual or insider access, you were completely locked out. But of course, that all changed. With the internet, everything became accessible. Manuals, internal documents, schematics. Suddenly, hackers could learn all about these once secret systems right from their keyboards. The very thing that was supposed to protect these systems, their obscurity, became their biggest liability. And then, in 2010, the world got definitive, absolutely terrifying proof of this new reality. It came in the form of a piece of malware so sophisticated, so advanced, it could only be described as the world's first true digital weapon, Stuxnet. Stuxnet was literally a ghost in the machine. It just slipped in through a simple USB stick, and then it silently hunted for its prey, a specific type of Siemens SCADA software. Once it found its target, it cloaked itself, becoming completely invisible to the people who were supposed to be in control. Then, using a stolen digital key, it seized the reins. It would physically damage equipment by spinning it way too fast, all while playing back a recording of normal operations to the controllers. I mean, they were completely blind, watching a ghost movie while their facility was being torn apart from the inside. This wasn't just a hack, it was a revolution in cyber warfare. So Stuxnet was a terrifying glimpse into the future of deliberate cyber attacks. But the threats to our critical infrastructure don't always come from some malicious outsider. Sometimes the biggest danger is already inside the system itself. And back in 2003, we learned that lesson the hard way. This entire crisis, a crisis that affected tens of millions of people, didn't start with some big bang. Nope. It started with a quiet, simple software bug in a single control room in Ohio. Just a tiny glitch in the SCADA system. And from that one little glitch, it was like a series of dominoes just started to fall. A power plant went offline. That meant the remaining lines got overloaded. They got super hot, and they started to sag down into some trees, causing them to short out. But here is the critical failure. That SCADA software bug meant the operators were flying blind. They couldn't see the problem, so they couldn't warn anyone. And the strain just cascaded, uncontrollably, across the entire grid. And the result? 55 million people plunged into darkness.
all because of one single software glitch in a system that was designed to prevent this exact thing from happening. In total, 256 power plants went dark. The physical scale of this failure was just absolutely massive, and it was a pretty stark reminder of just how fragile our interconnected world really is. So, what can we take away from these two events, Stuxnet and the blackout? Well, they really represent two sides of the exact same coin. The vulnerability of the systems that run our world, both to accidents and to deliberate attacks. Let's just compare them directly for a second. The 2003 blackout was an accident, a software malfunction that led to massive, widespread disruption. But a deliberate attack, let's say a more advanced version of Stuxnet, could exploit known vulnerabilities to cause targeted, calculated, and potentially far more devastating damage. Ultimately, the core lesson is right here. That blackout was an incredibly expensive and disruptive wake-up call. It proved, without a shadow of a doubt, that a small failure in the digital world can trigger an absolutely catastrophic breakdown in the physical world. And that leaves us with a final and pretty sobering question. We've seen what an accident looks like. We know what a targeted weapon is capable of doing. So what happens when a motivated attacker decides to combine the two, to intentionally trigger a cascading failure? That is something worth thinking about.